Today for notes, you need a straight edge. Actually, it needs to be a ruler. You need to be able to measure, and we're measuring in, where is it? Nearest tenth of a centimeter. Okay, so be sure you're looking at your centimeter side. We're going to measure all 3 side lengths of each of the triangles and record those measurements in the table below. Okay, so I don't think I need to walk with you about or talk to you about how to measure. I think you're pretty good with that, but if you have questions, please ask. Yes, Victoria.
What if when you're measuring and it doesn't come out very nicely? Do you go with the unnice number?
You're going to have some decimals, yes.
Oh, okay, we're writing them in decimals?
You are going to have decimals, yes.
If it's like
Yeah.
the line before the 4, can we just round it up to a 4?
No,
Where'd you get the line?
it'd be a 3.9, please. We want to be very accurate in our measuring.
Well, I got 4.
You're not measuring. Do you have to have them exact?
As close to perfect as you can get them is most helpful. Right now, we really don't want to estimate,
Alright.
if at all possible.
What is the tan, sin, and cos?
We'll get there. We'll get there.
Alright.
Right now, I just need your measurements, please.
I don't feel too long.
I'm just gonna write down yours.
So those are the measurements I have. If yours are pretty close to mine, then perfect. So now we're going to make some ratios. We're going to compare some sides. Now they're talking about opposite and adjacent and hypotenuse. Do you know where any of those are?
No.
What do you know?
Is the opposite? Well, I know where the hypotenuse is. The one with the angle.
Okay, let's start with that. First of all, hypotenuse doesn't necessarily have to be the angled one. The hypotenuse has to be the longest, and it has to be opposite that right angle. So it's possible that our triangle could be sitting differently on the page, and the right angle would be at the top, and the hypotenuse would be the flat side then. Okay, so it's the longest side, and it's opposite the right angle. Okay, great. Okay. We are supposed to use this skinny angle over here for what we call a reference angle, or the one that we're sort of looking at or trying to find information about. When we do these problems, it will tell you in the problem what angle to use. And it tells me right here to refer to the 20-degree angle. So reading those problems still are important to us. So where is the side opposite the 20-degree angle? Side opposite, right? Kind of hard to describe. Here's our side opposite the 20-degree, and this is our side opposite the 20-degree angle.
So the opposite depends on where your reference angle is.
Good, say it again, please.
So your opposite side depends on where your
Correct. You're the opposite side depends on what the reference angle is, or the angle that we're supposed to be working with.
Will it change if the 20 is above the right angle?
Yes.
So square thing?
Yep. So if the 20 was up here, then the opposite would be down there. So it does depend on which angle you're working with. Again, read your problem, make sure that you know what you're talking about.
Does that mean adjacent is the 4.9 centimeter and 3.9?
Correct. The bottom, if you will, of our triangles then is left to be the adjacent side. When I do trig, I do it the exact same way. I start with the hypotenuse, and then I find the side opposite, and the side that's left over is adjacent. The hypotenuse is usually the easiest one to find. Opposite is usually the next easiest one to find, and then adjacent is usually a little trickier. So I leave that for the end, feeling confident that I found hypotenuse and opposite first. Let's fill in some information here. They want us to write, excuse me, a ratio. And we're gonna round it to the nearest hundredth. So we're gonna need our calculators on, and we're going to need to be sure that they are in what is called degree mode.
Degree mode.
Yeah?
So we go bold.
Okay, so let's go to our calculators, and we need to be pushing the mode button. Hold on, I have to go back to my notes. Try that again. Degree mode. So push your mode button, slide down and over to the word degree and push enter.
What if mine's already on it?
That if yours is already on it, you don't have to change it. But for this week and next, you need to be sure you're in degree mode. And I'll try to remind you. Pretty soon it will become habit. Once we're in degree mode, we're ready to go. Let's write our ratios. So for triangle number 1, that'll be our triangle on the left. What is the side opposite and the side adjacent? So 1.4 is the side opposite, 3.9 is the side adjacent.
Oh, we do it in that little box?
We do it in the little box. We're going to put that into our calculator. 1.4 divided by 3.9. We are rounding to the nearest hundredth, so we're going to have 2 decimal places.
My calculator is actually weird.
So 3.6.
I ended up with that, only with E -1.
I'm sorry, I lied. Not 3.6, 0.36. And we're going to continue right on.
Did you amputate on it?
We're going to continue right on with the rest of the table. Going across, we'll still stick with triangle number 1. The side opposite divided by the hypotenuse. And again, going to our calculators to divide and round.
Would you do that for all the sides then?
Yep, we're going right, yep, we're going to end up making those ratios for all the sides. The side adjacent divided by the side that is the hypotenuse, and rounding to the nearest hundredth. Shifting gears, we're going to go over to triangle number 2. And we're going to jump right back into opposite over adjacent. Wow, those are pretty close values. Opposite divided by hypotenuse.
Are they all supposed to be those?
They should be, yes. Because we're starting this lesson at the sort of same place for both of these triangles. We know that they're similar because 2 of the angles are the same. So that third angle is going to be the same. So these are similar triangles. And we know that their sides are in proportion because they're similar triangles. What we just found is something called tangent, sine, and cosine. Go ahead.
In the first triangle for the opposite divided by the hypotenuse,
Yes.
wouldn't it be 0.33 repeating? You have to put the repeating sign over it.
They told us to round to the nearest hundredth, so we're not going to put the repeater. But yes, you're right. If the rounding hadn't been there, it would be a repeater. Very nice. So tangent of 20 degrees, this is the shortcut for tangent of 20 degrees. And it is our first value. And it looks like it's hovering somewhere around 0.36 or 0.37. Oh wait, I lied. Let's go to our calculators and do these. I apologize. Let's go to our calculators and do these. So I'm gonna clear out what I had. I'm gonna type in, do you see your tangent button? It's just above the number 9. And then you type in the number 20. I like to close the parentheses. And is that close to our ratio that we got?
Yeah.
All right, great. And let's just keep going right down, sine of 20, so I'm going to push the sine button, type in the number 20.
So it's all the buttons, we don't have to.
Right, you don't have to do anything special yet.
Nah.
Later this week, we'll talk about a little bit of specialness that we get.
Can those only work if we have a 20 degrees?
Oh, that's what we're going to find out later this week. We can actually go backwards and find out the angle measure from the sides. But that's for later this week. I don't want to ruin all the fun. Go ahead.
For the last one on our
Yes.
calculator where it says 9.939, we find out round up to
9.4. Yep, we're going to stick with that round to the hundreds. Yep, yep. So, filling in our little table here. We did a pretty good job with our measuring because all of our values in our table were pretty close to the actual calculator. Okay? Great.
Wait, you can just like pause it?
Yeah, that's what we just did. All right, so in the interest of time, I'm just going to give you the measurements for these triangles, and you're just going to trust me. Is that all right?
Yeah.
Okay, thanks. So this is our reference angle, our 50 degrees. So I'm just going to label my sides first. These are the sides opposite. Oh, I did it backwards, didn't I? I know my hypotenuse because it's opposite the 90-degree angle. Well said. The leftover is the side adjacent.
Do you have to get them right?
Yep. Or your ratios will be wrong.
Correct.
Okay? No pressure though. We'll do it a lot and you should be in pretty good shape. That is a decimal 2.5 for that side.
Still 9.
Oops.
I am not getting my measurement.
So now we're dealing with a 50-degree angle. You should notice that we have a little bit of different side length measurements, although they're not horribly different. Let's jump right in. Opposite over adjacent. And when I did my division, I got that. And I'm just going to stick with this same ratio and change problems, or change triangles. Opposite over adjacent. Hopefully everybody knows 3/4. But if you don't, your calculator is what will be helpful here for this division. And then opposite, or excuse me, adjacent over hypotenuse. It is for right. It is time consuming for today's notes, but your homework is not as time consuming. We need to go to our handy dandy calculators, push your tan button and type in the number 50. And then get those values for sine and cosine of 50. And you should have some matches or some close values.
Do we have to close the parentheses?
You don't have to close the parentheses for these trig functions. It's a good habit to be in, but not
Is there
necessary.
any more numbers after we do like the tangent 50 and parentheses and 50?
Yes, you can go down to degrees and minutes. And seconds. Degrees, minutes, and seconds. But that's not until Algebra 2 trig.
Good.
Yep. So, tangent of 50, sine of 50, and cosine. And again, those are close to the values that we got when we did our work. Still rounding to the hundredths place.
What's the homework then? There's no problems like this on there.
Right, this is just getting you comfortable, kind of explaining the background, if you will.